Okay, it's 5:11. This is going to be video number 71, and we are talking about assignment number 29. I mentioned in my letters, I'm not going to spend a lot of time on this. It's basically 7th grade math. However, if I assign you something, it's worth doing on the board. So I'll probably in this video end up doing all of them. And if there's a little time, I'll try to do some of the open-ended questions that the Regents asked. Literally, right off the book. I got it right in front of me here. So what's going on here? Assignment number 29, we gave you 26, 28, 30. We gave you the even ones till we got to the end. I'm tempted not to do each and every one, but let's just go over the basic principles when you're doing this math. Number one, when you add something to another expression, so what they're trying to do with the parentheses is tell you this is one expression and this is another expression. You just remove the parentheses and combine like terms. I'll do that in a second. However, when you subtract one expression from another expression, and the parentheses are there on purpose to tell you that it's an expression, a polynomial, an expression, I keep saying the same thing, then what you subtract, everything that's positive has to become negative. Everything that's negative has to become positive. That's subtraction in our new math, our polynomial math that you've seen in 7th grade. So with that in mind, I'm going to do 26 and 30. I'll quickly do number 28, and I'll try to get the other ones in without wasting too much of your time. And again, you're free to communicate with me by email to get this stuff done. Okay, so here we go. I'm moving over the advisor a little. Those are the problems. You have them in front of you anyway. And all I do here, I'm going to work vertically. You can work horizontally, different ways to do it. And I'm going to write this out. Okay, I could go sideways, but the main point is that the parentheses went away in the first expression. Here's the second polynomial. Everything goes away, and you don't take the opposite because you're adding. And so there we go here. These guys won't go together. They're not like terms. And then there's 2y. So maybe this is sort of in between these two guys. I'm careful about writing 3y cubed standard form followed by 5y squared standard form, and finally adding the y's, the like terms together, 10y, and there's my minus 3, which has nothing to go with it except the 0, and so this is a cubic polynomial with 4 terms. Okay, so quite reasonable expectation there. Okay, when we do a problem like this, I'll erase everything over here, and I'll do the second one so you can contrast the two problems. Easy ideas for real smart kids like you, high school freshmen. Here I go, babbling, but I'm getting the thing done here. So here we go, and this is subtracted from this. This has been explained to you. So what's it saying is remove the parentheses here, remove the parentheses here, but everything that's positive, you change to negative and vice versa. It's been explained to you. We'll go, again, vertically. No real reason for it, don't get me wrong. There's the first polynomial. And the second one, I'm lining them up. I don't know. A lot of kids really prefer, oops, there's a mistake there. The positive 5c squared becomes what? Negative 5c squared. And there's your positive 3c. Remember, weaker students, if there's nothing here, the first term is positive. That's 6th and 7th grade math. There's the negative 3, and the opposite of negative 8 is positive 8. So when I put everything together, I get 2c squared plus c. I left out the 1. We're getting used to that. Plus 2. And this is a quadratic trinomial. You should be able to see that. And these become very important down the road. Okay, very quickly, I'm going to do in my head number 28. That's the one I didn't do here. And number 28 is just putting h squares, h's together. In the other terms, everybody's positive. So to subtract this, this is why this is considered an easy one. Plus 4h plus 8. And you see the expression that's been subtracted from it. Everybody inside is positive, so it becomes a real easy problem. So they all become negative. Maybe that's the way you'd originally think about subtraction, but it really doesn't work that way. Again, everything that's positive becomes negative. Everything that's negative that becomes positive. Like terms, 2h squared. Like terms, 3h, and 8 minus 3 is 5. So there you got a taste of polynomial math, another quadratic trinomial. Get used to those little buggers. They're all over the place. So now we're at 5 minutes. I've done the first 3 problems. I wish you guys were in front of me because you give me so much important feedback. And you might say, come on, enough, stop doing this. So I'll do 37. And anybody who wants me to email an answer for the other 2 or the other one that I assigned, I'll be happy to do that. Or even if you like, I can put it on the assignment, the answer, because I have to do the other assignment soon as well. So let me just dry this off so I don't waste precious time. And now we go on. And I said I'd do, let's see, I assigned 35 and 37. I did 32. So let's do 37. And I don't know. Here's the z. They love z. Z turns out to be an important number down the road. So the parentheses means it's just some sort of expression. Quadratic binomial, if you really want to get into it. And I'm subtracting this other guy. Z squared. Notice my z's would look a lot like 2's. Minus 4. Okay. And finally, minus. And then how about this famous double negative? What does that say? Let's move this over just a little. We're keeping an eye on all this stuff. Minus, what does it say here? Z squared minus 2. And so here we go, the case number 37 here, where we have 3 algebraic expressions, but the principles are still the same. You could have 100 algebraic expressions. Nothing's really going to change. I'll do this one laterally instead of vertically or horizontally. I use the word lateral. You should be very content with that word now after the last test. And there's 2z squared minus 4. According to what I said, I just got rid of the parentheses. Negative becomes positive, so that becomes that. And there, this becomes that. It's been explained to you. This time we're going left to right. There's the opposite of 3z, negative 3z squared. And there's the opposite of 2. So I just don't see why your average 8th grader, never mind 7th grader, never mind Regents student wouldn't be able to do these problems. So we got to be a little careful here. There's 5z minus z. So I come up with 4z squared. And that was the highest degree that I saw. And the rest of the numbers, this cancels. So I came up with 2. Hey man, factoring comes up right away. Well, we don't know about that yet. So this is a quadratic binomial. And really it should be factored, but we'll leave that alone for now. Okay, so now I'm up to 9 minutes, and I still have some time. And I mentioned in the letter this morning that I do a bit of work on the open-ended questions that follow number 37. So I'll just get them out there, and I'll ignore the perimeter questions because I'll be talking about that soon, and they're so easy anyway. And now I'll do some of the problems. This is problem number 39, and I think it's they're really right to ask this question, so I'll get it out to you. And then I'll just do it. So you'll see the kind of questions that the authors of this book were interested in. It says, is 2x to the negative 3. Whoops. Not a nice one. Make it nice. to the negative 3, and then they add plus x squared plus x minus 4. So is this a polynomial? And this was discussed with you, and you'd be expected as a Regents student to answer this question correctly. So I'll pause for a second and then give you the answer. Normally in class we'd be talking about this, right? So that's the first Regents question that they want to see if you get the concept. So the answer, of course, is no. And the reason is you can't have a polynomial with negative powers. Now you can have algebraic expressions where the algebraic expression is in the bottom, but we're not there yet. They're asking you a simple question. If you have a negative exponent, or you've rewritten it, which they chose not to do, like this, which is the equivalent, you are not a polynomial. Reason, you have an exponent that's less than 0. So, fair question. Here's another one that they ask, which I think is worth answering to you. And this is going to let you think about it just for a second. This is the last question. It's number 42, and it's a concept question. And you know I love those. I always like concept questions. And I'll write it out, and then I'm going to go on a while for the answer. So it says, is the sum let me get out of your way here, of two binomials, because this is what makes math fun anyway, right guys? Is the sum of two binomials always a binomial? So you can, you can think about that for a second. And we're up to 12 minutes now, so I only got about 2 minutes to do this. And we could expound quite a bit more on this, but what's the answer going to be? Always? Well, I'll tell you what. How about 2x plus 1? Isn't that a binomial? Two unlike terms? Does every polynomial have its opposite except 0? Absolutely. We showed that to you before. So what's the opposite of 2x plus 1? Minus 2x minus 1. Is that a binomial? Of course. When I put them together, what do I get? Is 0 a binomial? No. 0 is a monomial, one number. So I'm going to expand the question just a tiny bit, and I'm going to ask you, what is the highest degree you can get from adding two binomials? The lowest degree is obviously 1. What's the highest degree you can get? Well, if you think about it, I'll make up a problem, and I'll say this is x cubed plus x, and I want to add to it x squared plus 1. So if I have two random binomials which don't have the same power, then of course what do I get? And you should think about what I just did, because this is called thinking abstractly about the math. You get a cubic polynomial, 4 degrees, which we've come up against again and again. So the answer to this question that they're asking you to think about things is, the answer is no. Now, you might say, can you get a monomial when you add two binomials? How about this example? There you go. There's a monomial. And you could add the powers and do something like that. So anyway, that was the question number 42. I answered it, and we always want to keep enrichment in mind. Okay.